How do you teach an AI to do something complex, like play a game or control a robot, without having to write millions of lines of code for every single possible scenario? It sounds like it should be impossible, right? Well, it turns out the answer is surprisingly elegant and simple. Today, we're going to dive into this powerful idea of goals and rewards, which is really the foundation of how these AIs learn. So let's start with the big question. How do you actually communicate a goal to a machine? You can't just talk to it and say, hey, go win this game of chess. It doesn't understand instructions the way we do. It needs a clear mathematical signal to know if what it's doing is good or bad. So what's the trick? How do we actually do it? And here's the beautiful part. And honestly, it's what makes reinforcement learning so cool. We don't use some huge, complicated instruction manual. Instead, it all boils down to just one single, powerful signal. This one little thing is what guides the entire learning process. And as you'll see, it's a super simple idea, but man, it can unlock some amazingly complex behaviors. All right, so let's dig into that. To really get this, we've got to understand why this one signal, what we call a reward, is so absolutely crucial. It really comes down to a totally different way of thinking about how to give an AI its marching orders. See, this is the big mental shift you have to make. Normally, with old-school programming, you're the micromanager, right? You tell the computer exactly how to do everything, step by step by step. But with reinforcement learning, we kind of take a step back. We don't spell out the how, we just define what the end goal is. And then, we let the AI figure out how to get there all on its own, through pure trial and error. And this whole approach is built on this really foundational principle. It's called the reward hypothesis. It's a bit of a fancy name, but the idea is actually super simple. That pretty much any goal you can think of can be boiled down to just one objective. Get the absolute biggest pile of rewards you possibly can over time. So the AI isn't just thinking short-term, like, where's my next point? No, it's learning to maximize its total score for the entire game. Okay, I know that sounds a little abstract. So to make this all click and feel way more intuitive, let's use a simple analogy. And we're going to stick with this one for the rest of our chat. It's all about training a dog. I mean, think about it. If you want to teach your dog to fetch the paper, you're not going to sit down and write a textbook for him, right? Chapter 1, the physics of a proper trot. Chapter 2, jaw pressure and newsprint integrity. That's just silly. Instead, what do? You use something way simpler and way more effective. Treats. That little piece of positive feedback is everything the dog needs to start connecting the dots. So let's break down how this maps over, because it's a perfect fit. The AI agent we're talking about, that's your dog. The goal we're trying to teach it, well, that's fetching the newspaper. The environment it's operating in, that's your house and your yard. And that simple, powerful signal, you guessed it, that's the treat. That's our reward. All right, so the idea of a reward seems pretty straightforward, but there are a few important layers to unpack here. We need to break down how we actually construct a goal from 3 key building blocks. There's the immediate reward, there's the long-term objective, and then there's this really interesting idea of why getting something now is almost always better than getting it later. So let's start with the most basic piece of the puzzle, the reward signal. Honestly, the easiest way to think about it is just as a point system. For every single action the agent takes, the environment gives it a number. A positive number is like a good job, that's our treat. And a negative number is a nope, try something else, that's our penalty. Let's bring it back to our puppy. The reward signal is that single treat you give the dog for doing one tiny thing right. Maybe he just manages to pick up the paper off the lawn. You're not waiting for him to bring it all the way back, you give him a treat right then and there. It's not for completing the entire job, just for that one successful step. That's the immediate feedback we're talking about. Now let's look at a classic AI example. Training an AI to be a taxi driver. In this little world, the AI might get a big, juicy plus 20 points for a successful drop-off. Awesome. But if it messes up, like making an illegal pickup, it gets hit with a -10 penalty. Ouch. But here's the really clever part. It also gets a tiny -1 penalty for every single move it makes. Why do that? Well, that tiny constant negative reward encourages the AI not just to get the passenger there, but to find the most efficient route possible. It learns to stop wasting time. Okay, so individual rewards are great, but an AI that only thinks about the very next treat is going to be pretty short-sighted. It needs a bigger picture, a long-term goal, and that's what we call the return. You can just think of it as the grand total of all the rewards the agent expects to get from now until the end of the game. So the real goal isn't just snagging the next point, it's maximizing this huge total score. And this is such a critical distinction. The dog isn't just learning a simple rule like, if I pick up the paper, I get one treat. No, it's learning the entire chain of events. Go out the door, run across the lawn, grab the paper, come all the way back inside. The whole sequence that results in the biggest possible pile of treats. That whole pile, that's the return. This brings up a really interesting question, though. We know we want the biggest pile of rewards, sure. But should we care about when we get them? I mean, think about it. Is a treat that you're going to get right now worth the same as a treat you might get 10 minutes from now? I think we all know the answer to that, and our dog definitely does. Of course not. A treat in your hand right now is certain, it's immediate, it's super valuable. But a treat that's way off in the future? Who knows? It's less certain, there's a delay, so naturally it just feels less valuable. We're all kind of wired to prefer instant gratification, and it turns out, so are our AIs. So we actually have a formal way to handle this preference. It's called the discount rate, and we usually write it down with the Greek letter gamma. All it is a number between 0 and 1. And you can think of it like, well, kind of like an interest rate, but in reverse. It systematically makes rewards that are further off in the future worth less today. It just makes those immediate rewards much more tempting. Let's make that concrete. Imagine our discount rate is, say, 0.9. A reward you get right this second is worth its full value, 100%. But that same reward, if you have to wait just one step to get it, is now only worth 90% of its original value. And if you have to wait 2 steps, its value drops again, down to just 81%. You see that decay? This is what pushes the agent to not just find a solution, but to find a solution that pays off sooner rather than later. All right, so let's do a quick recap. We've got our building blocks. We have the immediate reward signal. That's our treat. We have the long-term return. That's the whole pile of treats. And we have the discount rate, which makes treats now better than treats later. So now, let's put it all together and see how this actually works in a real learning loop. It all works in this continuous cycle, over and over and over. So, step 1, the agent observes its current situation. Our dog sees the newspaper on the lawn. Step 2, it takes an action. The dog decides to run and grab it. Step 3, it gets a reward. You give it a treat. And here's the most important part. Step 4, it updates its internal strategy. It learns, hey, when I saw the paper and ran to it, I got a treat. That was a good move. I should do that again. And it just repeats this loop thousands, millions, even billions of times, getting a tiny bit smarter with every single cycle. Okay, we have covered a lot of ground. So what's the one big idea, the key takeaway? If you only remember one single thing from our entire chat today, I want it to be this. The big takeaway is that in reinforcement learning, a goal isn't a list of instructions. It's a drive. It is a simple, relentless hunger to get the biggest possible score over time. That's it. All the incredibly smart, complex behaviors we see, they all bubble up from this one simple principle. But this also leaves us with a really important, kind of scary question for anyone building these systems. Are you absolutely sure you've designed the right reward? Because the AI is going to do exactly what you reward it for. And that might not be what you actually intended.